Okay, assalamu alaikum. Good evening, everyone. I hope you are all doing well. Welcome and thank you very much for joining today's webinar, Basic Statistics for Analytical Chemistry Laboratories, which is very important subject for each laboratory and each field of laboratory works. I am very happy to meet you today. My name is Mohammed Elwawi. I am laboratory manager with over than 28 years of experience in petroleum industry, oil and gas laboratories, and water analysis and water treatment. I have also studied statistical quality control and quality assurance through postgraduate studies. Today's session is introductory and basic session. We need to know the basic of statistics and statistical calculations to apply it and make application of these statistics for analytical chemistry laboratory. I also plan to conduct more webinars. Mr. Billy join us, inshallah, in the future and go deeper into statistical quality control and its application in laboratories in detail. So our session today is a basic session. It's a fundamental basic statistics concepts. My goal is not only to share knowledge, but also to connect with laboratory professionals and exchange experience among global countries. This session will be recorded and will be available later on my YouTube channel. Our webinar today will be around 1 hour. We will keep the question and discussion at the end to the end of the lecture. So now let's start our learning objectives for this day. Mr. Muhammad, you are with me? Muhammad Fathi. I think there is some issue and also Mr. or Miss Oliwa Fimi. You can hear me, Mr. Oliwa? I don't know if I read it right. Oliwa Fimi. Okay, maybe there is some issue in the mic. So let's continue. Mr. Billy, you are hearing me well, right?
Yeah, very well.
Okay, let's start. Let's start our learning objectives. Our learning objectives, by the end of this introductory session, we will be able to first differentiate between types of laboratory data. First, we should know before we apply any statistical calculation or statistical tests, we should know our data type. We should differentiate between types of laboratory data. Then also we will be able to understand the importance of statistics and what it meant by statistics in laboratory data analysis and interpret basic descriptive statistics such as mean, median, range, and standard deviation, and understand the importance of each parameter. Also relate the normal distribution curve and what's meant by normal distribution curve to laboratory measurement variation, and understand the principles of statistical control chart to monitor process stability, which is a very important tool used in any laboratory and special for laboratories tend to be accredited with ISO 17025. And also, we will be able at the end understand the principles of hypothesis testing, which is very important uses in our laboratories. So first, we will discuss the types of laboratory data, which is very important because they give us the decision to choose a specific kind of control chart that relate to this data, or hypothesis testing relate to this data. This classification is important because before choosing any statistical method, we must first understand the type of data we are dealing with. So we have two main types of data in laboratory. Of course, we have quantitative data and qualitative data. They are the famous categories of data in the lab, and we can call them also variables data and attributes data. Variables data, it is the quantitative data. They are measured numerical data. They can be discrete numbers or continuous numbers, as in pH results, density results, viscosity, sulfur content results. They are all variables data. They are quantitative data. We can give them a magnitude, discrete value or continuous value. Also, we have attributes data. Attributes data is categorical data. They can be binary data, nominal data, ordinal data. They are qualitative data like pass or fail, accept or reject, sample type. Binary data have only two possible categories or outcomes, maybe pass, fail, yes, no, conforming or non-conforming. Nominal data are categories or names with no natural order or ranking. As in water samples, if we have water sample, we have different water sample like drinking water sample, wastewater sample, seawater sample, cooling water sample. They are called, all these samples called nominal data. Also, we have ordinal data. Ordinal data are categories that have a clear order or ranking, but the difference between the categories is not necessarily equal. Like turbidity, we have low turbid water, medium turbid, high turbid, and also as hardness of water, we have soft water, hardness water, very hard water. We can call these data attributes data or categorical data. So here the main question in laboratory work, we ask ourselves, when we repeat the same chemical analysis, why do we not always get exactly the same result? In real laboratory work, repeated results are rarely identical. The key question, is this variation just normal? As in this example, when we determine the pH of sample, water sample, for example, we get these results 7.21, 7.24, 7.20. They are not identical results. Why is that? We should ask ourselves, is this variation just normal variation, or there is a problem, need to take corrective action to correct our instrument, or there is an issue in the analyst work. So there is a variation, always we have a variation in our laboratory. To determine this variation and to accept or reject this variation, we need to make some statistical calculations and use some statistical tools. Variation, of course, has many possible sources in the lab. Maybe sometimes if it comes from the instrument performance or analyst technique, maybe sometimes, or the agents and standard conditions, if they are expired or some issue in them, and also in from the environmental condition. Maybe the weather is very hot, or there is a humidity in the weather affect our results. Also, the calibration, we should calibrate our instruments if there is anything in the calibration, any issue. So this is we have a variation in the results. Also, the method limitation. Every method, we calibrate the instrument, our instrument, in certain range, limit of quantification and limit of detection. If the result is out of this limit, So there could be variation in the result. So sometimes small differences do not always mean error. How we can judge that? How we can take the decision if this small difference is affect our result or it's normal, no problem. We should use statistics in calculation. So what is statistics in the lab? Statistics as general is the science that deals with data and data analysis. Of course, in lab, it is the science of collecting, organizing, analyzing, and interpreting laboratory data to support reliable technical and quality decision. So in our laboratory, statistics mean first collecting the data, then organizing the data, then analyzing and interpreting the tests or tools that we are using in this process to take reliable technical and quality decision at the end to determine if we accept this uh, results or not. So statistics help us understand what the result if there is or there are the result is stable or not, is there trend, is there significant dispersion around the mean, is there a problem that requires corrective action. So statistics tells us or help us understand what the numbers tells us. Of course, we statistics in laboratory quality. Statistics help laboratory quality. It supports quality control. In quality control, we use them to monitor the result of control sample. We are using control chart, we're using flow chart, we're using check sheet. These are all statistical quality tools we are using in our laboratory to ensure the quality of laboratory. Also, statistics support method variation. In method variation, we use the statistics and the statistical calculation to determine the precision, the accuracy, the linearity, the limit of detection and limit of quantification. They are all statistical calculations. Also in measurement uncertainty calculation, we use statistical parameters to determine and to estimate the measurement uncertainty. Also in proficiency testing, which is very important requirement in ISO 17025. We need to determine the Z-score. How we determine the Z-score? By statistical calculations to compare the laboratory work. Also in continuous improvement in the lab by using KPI tools to improve our work. Also, statistics support also ISO 17025 or statistical thinking help laboratories to be accredited in ISO 17025. First, it ensures validity of the results by using tools such as mean, standard deviation, recovery, precision, and measurement uncertainty. We ensure the validity of our result. Also in monitor laboratory performance by using control chart to determine if our process is in control or out of control. Also evaluate quality control data. How we can evaluate quality control data. Quality control results can be assessed statistically by comparing them with control limits, warning limits in the control chart, acceptance criteria, and historical performance. Also, it supports technical records and supports, of course, non-conforming and conforming results. Also, it provide objective evidence during audits. It gives us a objective evidence for the auditor to give him trust on our results during audits. So statistics, we are using statistics in the lab, and they are very important in our labs. Now we will discuss the types of statistics. The main types of statistics are descriptive statistics and inferential statistics. We have descriptive statistics and inferential statistics. Descriptive statistics is the branch of statistics used to summarize, organize, and describe the data, present data in a clear and meaningful way. But inferential statistics is the branch used to make conclusion and decision about sample data. So inferential statistics use descriptive statistics to deduce a conclusion and make a decision about the sample data, if we can accept this data or not, or what we can do with this inferential statistics. So when we will discuss the descriptive statistics first, descriptive statistics has two main components. It has measures of central tendency and measures of variation or dispersion. Measures of central tendency describe, as we say, describe the center or typical value of the data. It gives us information about the center of the data or typical value as mean, median, mood, parameters. Also in measures of variation or dispersion describes how much the data values spread around the center. We have range, variance, standard deviation. They give us the information of how these data are spread around the mean, if the data are close to each other and close to the mean, or they are away from the mean. So central tendency tells us where the data are centered, while variation tells us how widely the data are spread. We will discuss in some detail a measure of central tendency. We say that it composed of mean. Mean is the average or the arithmetic center of the data. Of course, we will take an example of how to measure that or how to calculate it. And also we have the median. The median is the middle value in an ordered set of data. If we have a set of data, we order this set ascending or descending, and the median is the middle value. The mode is the most frequent value in the data, the most repeated value in the data, as in the following example. So if we have a water sample and we want to determine the iron in this water sample, we repeated the measurement 5 times and obtain these results. 0.48, 0.50, 0.50, 0.51, and 0.56, for example, milligram per liter. So when we determine the mean means sum all these data and divide it by its count, divided by its by 5, because they are 5 measurements. So the mean will be equal to 0.51 milligram per liter. The median, we order this set of data ascending or descending and choose the middle value. And here the middle value was 0.50. The mode is the most repeated value. The value that repeated twice or 3 times or 4 times, most repeated value. In this set of data, it was 0.50. The mode is 0.50. The mean is, of course, still the most commonly used measure because it uses every result in the dataset. It is mathematically suitable for further statistical, of course, calculation, as we use the mean to calculate the standard deviation, the variance, the control limits in control chart, the confidence interval. So the mean is the most important parameter in the central tendency. Also, we have the measures of variation of dispersion, and we said that they are three parameters. Range is the simple calculated parameter, which is the difference between the maximum value and the minimum value. Also, we have the variance. Variance is the average of square deviations from the mean. And also we have the standard deviation, which is the most commonly used parameter in statistical calculation. It is the square root of the variance. And standard deviation tells us how the dispersion of the data around the mean. As in this picture here, if we have low variation, low standard deviation, that means if the results are close to each other and close to the mean. Here the mean is equal to 100 and the data of the value of measurement are close to each other and close to the mean. In the opposite picture, if we have high standard deviation, that means we have high variation or high dispersion of the data. That results are more spread out around the mean. If the mean is 100 and the data is spread, so they are away from each other and away from the mean. That means we have a high dispersion of the data and low dispersion of the data. Course, these give us an information about the data. As in this example, the same example, we repeat the measurement of iron analysis in water 5 times and get the same results. When we want to determine the range will be equal to the maximum value minus the minimum value. It will be very easy. In this example, it will be equal to 0.08 milligram per liter. When we determine the variance, which is the square root of the deviations of the values from the mean, we get this value 0.0009 milligram per liter square. If we concentrate here, when we determine the variance, we get a unit square. The unit here is square, but our unit is milligram per liter, not milligram per liter square. So the scientists thinking and deduce new parameter, which is the standard deviation. Standard deviation is the square root of the variance. So standard deviation here, when we calculated it, equal 0.03 milligram per liter. So it is the same unit of our measurements. So the most practical and widely used measure in laboratory quality control is the standard deviation because it brings the variation back to its original units such as milligram per liter here or ppm. So this is the descriptive statistics. Also we have a visual description of the data when we use the standard normal distribution curve. We call it sometimes the bell curve because it takes the shape of bell. So it is used to describe how data are distributed around the mean also. In laboratory work, when we repeat the same measurement several times under stable condition, the results are usually not exactly identical. However, they often vary around the average value in a predictable way. So the horizontal axis here in this normal distribution curve represents standard deviation from the mean. Here is the mean, and here is one standard deviation, two standard deviation, three standard deviation. According to empirical rule, we have an empirical rule related to this normal distribution curve according to this rule, about 86.3% of our data or our results lie near to the mean between one standard deviation and minus one standard deviation. And around 95% fall within 2 standard deviation, and around 90.7 of our results will fall within 3 standard deviation, between positive 3 standard deviation and negative 3 standard deviation. Why this normal distribution is very important, and in which tests we are using? We use some tests, some hypothesis tests that we are using to compare results or instruments need that our results in the lab to be to follow the normal distribution. So normal distribution gives us the decision to choose which test, hypothesis test, to use it in our calculation and our statistical calculation. How we can determine if our data in the lab is follow normal distribution or not? We use software, statistical software, such as Minitab or SPSS programs, statistical package for social science. These software programs provide normality test. We test our data, we give the software our data and test if this data is normally distributed or not. We have some statistical tests like Shapiro test or Kolmogorov-Smirnov test. We use them to test if our data is normally distributed or not. We will discuss this more when we discuss the hypothesis testing. It will be clear. So now, after understanding descriptive statistics, we now move to inferential statistics, the other type of the statistics. So descriptive statistics help us summarize and describe our data, such as calculating the mean, the median, the range, and the standard deviation. They are all descriptive statistics. But in laboratory work, we often need to go further. We need to make a decision based on data. This is where inferential statistics are used. Here, there are two main components that will be briefly introduced here in this slide. We have hypothesis testing and correlation and regression. Hypothesis testing, we use these hypothesis testing to compare when we have a claim or assumption about data is statistically significant or not, and we want to compare analysts or compare old method and the new method, or compare any two types of data. We use hypothesis testing like t-test and ANOVA test. We will talk in more detail about these tests in the next slide. Also, we have correlation and regression. Correlation and regression, of course, relate the variables to each other. We use correlation and regression to relate variables to each others. We use correlation if you use it before, which is R, coefficient of correlation. We use this coefficient of correlation calculations to determine the power and the direction of the relation of between two variables. As for example, if we have concentration and absorbance, we determine the absorbance of different standards of concentrations. So we want to know if this relation is directly proportional or inversely proportional, or if it is strong relation or weak relation, or if there is no relation. So we use what is called correlation coefficient or coefficient of correlation. Also, we have a regression analysis like simple linear regression. In our laboratory work, we call it least square method. It gives us the equation that we can use to determine the dependent variables when we have independent variables and the relation between them. It gives us the equation when we have y equal to a plus b multiplied by x, where a is the constant, b is the slope. So simple linear regression determines this equation exactly and gives us information about the relation between the two variables, the independent variable and the dependent variables. Also, as we say, we have examples of hypothesis testing because some people don't know what's meant by hypothesis testing. Hypothesis testing tests are very useful in chemical laboratory because they help us make objective decision based on data. Of course, we have many types. Here are four examples. We have one sample t-test. We have paired sample t-test, one-way ANOVA, two-way ANOVA. One sample t-test we use can be used when we want to compare the average results of a sample of different measurements of the same sample, repeated measurements with a certified reference value. If we have a certified reference value and we want to compare different measurements with this certified reference value, as for example, when we analyze certified reference material for iron in water, we want to determine or we want to use the one sample t-test for different measurements of iron in water. Suppose we have a certified value 0.50 milligram per liter, and we make repeated measurements, and the average of these measurements was 0.52 milligram per liter. The question here is this laboratory mean significantly different from the certified value or not? We can accept this value and our instrument is working properly and analyst is working properly, or not, or there is a difference need to take to determine this. We need to determine the one sample t-test. You can see the chair, please. Mr. Ala, you can see the chair? Okay, Mr. Muhammad, you can see the chair? Okay, I will continue. Also, we have paired. You can see the chair, anyone? Okay, I think there is some issue in the net. So I will continue. We have also paired sample t-test. Paired sample t-test is useful when we use the same samples using two methods. For example, an old method and a new method, and we want to compare if the old method is gives the same result as the new method. So we use paired sample t-test. Also, in one-way ANOVA test, we is used when we compare more than two groups of one factor. And two-way ANOVA test, we use it to compare two factors as when we determine the turbidity in different times and different location. We use, for example, for water, we use the two-way ANOVA test. So we have two main types of hypothesis testing. We have parametric tests and non-parametric tests. As we said, the normal distribution is very important because parametric test assumes that the data should follow normal distribution. But in non-parametric test, the data shouldn't be. It can be normal distributed or any different distribution. Also, we have a parametric test. In parametric test, we have continuous data. In non-parametric tests, we have ordinal, nominal, or continuous data. We can use it. But in parametric tests, of course, we have, it's important because it is higher statistical power than non-parametric tests. In parametric tests as t-test or ANOVA, and non-parametric tests is as Wilcoxon, rank test, Kruskal, and others. We finished now the hypothesis testing, and we will discuss the statistical quality control tools we are using in our laboratory. Of course, these are very important tools. The Walter A. Shewart was the father of statistical quality control. He introduced the concept of distinguishing between common cause variation and special cause variation. He invented the control chart in 1924, in the year 1924. And the statistical quality control tools are 7 tools. They are check sheet, histogram, Pareto chart, scatter diagram, cause and effect flow diagram, control chart. Check sheet used to collect and organize data. Histogram used to show the distribution of laboratory results by grouping data into ranges. Pareto diagram used to identify the most frequent or most important causes of problems. It operates on the 80-20 rule. The principle that roughly 80% of process defects stem from 20% of causes. A scatter diagram used to study the relationship between two variables, as in calibration curve. Cause and effect diagram, sometimes we call it Ishikawa diagram, used to identify possible causes of quality problem. Flow diagram, as we use in our laboratories, as a worksheet near the instrument. And the last one is the control chart. Control chart is a very important tool we are using in our lab. It consists of 3 components. The central line represent the average or the mean value. Control limits, the upper control limits and lower control limits. As in this picture, this is the picture, or this is the image of the control chart. If we have the mean value of our measurement equal to 0.50, we calculate the warning limit, which is orange color, and action limit or upper control limit, which is red color, and also warning limit below the mean value, and the lower control limit. If our results lie between these two action limits, or upper control limit and lower control limit, we say that our process is in control. If any point lay about outside these control limits, we say that our process is out of control and need to be corrected and take a corrective action. We have, of course, kinds of control chart. We have variables control chart and we have attributes control chart. As we said in the beginning of the session, we should determine our data, determine the kind of our data, if it is variables data or attributes data, because it gives us the information to take the decision which control chart we are using in this data. We have three types of variables control chart: individual moving range chart, when our measurement is equal to one each day or one each month, one measurement only. We have X bar and R chart. Also, when we have the number of measurements equals to 2 or 9, if the number of measurements is more than 9, is equal to 10 or more than 10, we use different control chart, which is called X bar S chart. S here is the standard deviation. Also, we have the second kind. It is attributes control chart. We have B chart and NB chart. B chart is proportional defective. If we want to determine any defect by counting the defective in the lab, we use B chart for proportional defective and NB for number of defective number. So now we arrived to the end of our session. I hope it was very useful. Before we move to the discussion, I would like to end with this message. To measure is to know. To validate statistically is to trust. Trust our measurements. So statistics help us move from simply reporting numbers to making confident, technical, and quality decision. Today we covered the basic foundation, types of laboratory data, and we discuss descriptive statistics, normal distribution, hypothesis testing, statistical quality control, and control chart in a briefly, of course, discussion. These are only introductory concepts, and in future, inshallah, sessions, we can go deeper into practical and applications in real laboratory examples. Now, I would like to thank you very much for your attendance, your time, and your interest.